2. All right. So continuing along, chapter 8 on matrices and determinants. So now we want to look at for, section 8.2, inconsistent and dependent systems and their applications, right? So again, in the previous section, we explored solving a system of equations using row operation and matrices. So now we want to see what happens like when there's no solution or infinitely many solutions, right? We have some weird things that happen. So a few objectives here. We like to apply Gaussian elimination to systems without unique solutions, apply Gaussian eliminations to systems with more variables than equations, and solve problems involving systems without unique solutions. Okay, so let's see this in action. We can use Gaussian elimination of systems with 3 or more variables to determine how many solutions such systems may have. In the case of systems with no solution or inconsistent, or infinitely many solutions which are dependent, it is impossible to rewrite the augmented matrix in the desired form with 1s down the main diagonal from upper left to lower right and 0s below the 1s, right? So if the system is either inconsistent or dependent, we're not going to be able to get that reduced row echelon form. So here we're asked, so that's kind of like a foreshadowing or you know, we might see something funny here, right? So use Gaussian elimination to solve the system. Can I paste that page? That would be nice. Oh, okay. Well, that was too much like right. This is slide 5. I feel like I might need it. Let me just copy. If I can get this thing to paste. Copy. Can I paste it? Come on, you can do it. Why do you take so long? I don't understand. Copy. That should not take that long to do all that. There it is, paste. Nice, okay, this is exactly what I want. I'll just go for 1 for right now. Okay, so with Gaussian elimination, remember the goal is to get 1s along the main diagonal and then 0s everywhere else. And then when we do it properly, the answer is going to be shown. But there's a good chance that we might not be able to do it. Okay, so first let's get our augmented matrix. So we take our coefficients. We have our 1, -2, -1, 5, 2, -3, -1, 0. We have 3, -4, -1, 1. Okay, let me clean up that one. Why are you writing like that? Well, thank you. Okay, that looks decent. So we already have a 1 in the upper left. So now let's use that 1 to get 0s below it. Okay. But then what we'll do, we'll say a -2 times row 1 added to row 2, replace row 2. We're going to say -3 times row 1 added to row 3, replace row 3. Okay. So that means row 1 stays as is, 1, -2, -1, 5. Row 2, so -2 plus 2 is 0. 4 minus 3 is a 1. 2 minus 1 is 1. -10 plus 0 is -10. And then row 3, let me see. -3 plus 3 is 0. 6 minus 4 is 2. 3 minus 1 is 2. What is that? -15. Yeah, it's getting weird. -15 plus 1 is -14. Okay. So we've gotten our 1 with 0s below it, and we already have a 1 here with a. Now let's use that 1 to get a 0 below that. Okay. So I'll do that by saying a -2 times row 2 replace plus row 3 replace row 3. Okay. So that means row 1 stays the same. 1, -2, -1, 5. Row 2, if we distribute the -2, actually row 2 stays as is. So this is 0, 1, 1, -10. Now row 3, that's a 0. -2 plus 2 is 0. -2 plus 2 is a 0. And then 20 minus 14 is 7. So notice in that third row, we have 3 zeros, right? So we won't be able to do any row operations to get this guy to be a 1, to preserve the work that we've done and to get this to a 1. So when we get like a row of zeros like that with it being a false, like 0 equal to some non-zero, this means that there's no solution, right? This row of zeros, because we won't be able to get a 1 here, right? So there's no solution. Yeah. Is it like no solution? Yeah, so that means it's no solution. Okay, let's look at our prepared notes for this. Didn't need that page. Maybe I need to stop adding the page. Let's delete that page. No, don't do that. Okay, let's go back. This one. All right, that looks good. Did we delete the page? Nice, okay. Okay, so we got no solution. So looking at our prepared notes, write it in the augmented matrix using row operations. Notice they got the row of zeros, okay? Attempt to simplify the matrix to row echelon form, all right? In the equation form, the last row will be 0 equals -4. This equation can never be a true statement, so the solution set is the empty set. That means no solution. Empty set is just a 0 with a slash through it. 0 with a slash through it. I guess you guys are okay. Let's keep going. Okay. Yeah, I got like a bunch of paperwork I need to do. Okay, not too bad. We're already halfway through this one. Notice, look at the title. It says a system with infinite number of solutions. Let's see the infinite number of solutions, right? Use Gaussian elimination to solve the system, okay? So let's write the augmented matrix. So the coefficients, we're going to have 1, -2, -1, and 5. 2, -5, 3, and 6. 1, -3, 4, and 1. Okay. And we're going to go like this. Okay. So we already got a 1 here. So that's our first goal. Then we want to use that 1 to get zeros below it. Okay. So let's say -2 times row 1 plus row 2 replace row 2. Okay. We're going to say a -1 times row 1 plus row 3 replace row 3. Okay. So with this, I see like the one time I don't add the page, I feel like I might need it. But let's just keep going. Let me just see what happens. Let it unfold, right? So row 1 stays as is. 1, -2, -1, 5. Okay. So then -2 plus 2 is 0. 4 plus -5 is -1. Okay. 2 plus 3 is a 5. -10 plus 6 is -4. Okay. And then with row 3, -1 plus 1 is 0. 2 plus -3 is -1. 1 plus 4 is a 5. -5 plus 1 is -4. Okay, you should notice something with these rows, right? Okay, let's get the center. Let's get the center guy to be. Well, actually, we don't even need to do that. Let's just say a negative times row 2 plus row 3 replace row 3. So I'm going to say a negative times row 2 plus row 3 replace row 3. Okay, and I'm just going to bring it over here to the bottom left. So that means row 1 stays as is, 1, -2, -1, 5. Row 2 stays 0, -1, 5, -4. Now, if we say do this row operation, we get a 0, we get a 0, we get a 0, and we get a 0, right? I did that. I went on and just jumped straight here because I saw it, right? So notice this time we got an entire row of zeros, right? And so if we were write out the equation, this would be what? 0x plus 0y plus 0z equals 0, right? So when we get an entire row, that's a true statement. So when we get something like that, that means we have infinitely many solutions, right? So what we do in that case, we let our z be a free variable. We're going to call it a, okay? And then from that second row, that says what? Negative y plus 5z, so that'll be plus 5a equals negative 4. If we solve for y, okay, I can add y and add the 4. We get y equals 5a plus 4, okay? So we get z equals a, y, we got y in terms of a. And then from the first row, we get, that says what? X minus 2y. Our y is 5a plus 4. Minus z, which is a, equals 5. So we want to expand this and solve for x, okay? We'll get x equals, it should be 5 plus 10a plus 8 plus a. So then x equals 11a plus 13. Okay. Let me see. So another way we write it, we could say x, y, z, the variable matrix equals, so x takes on the form 11a plus 13. Y takes on the form 5a plus 4. And z takes on the form of a. So it has infinitely many solutions where a can be any real number. So if you choose your favorite real number, plug it in, you can test to see, you know, the 3 numbers generated to make sure they work in the original, right? So this has infinitely many solutions, and this is how we do that. Hey, Google, give me a random number.
Here's a random number, 80.
I mean, that's a little extreme. So let's just do 8, right? We can do 80. It would work, but I'm trying to keep it somewhat simple. Okay, this is just an A. Okay. So if we let A be 8, right? So if we let A be 8, this is a test point. That's 88 plus 13, 88, 98, 101. So then we could say 101. What is that? 44 and 8. That should be an ordered triple that should make the solution true, right? All we did was let A be 8, plugged it in. That should be one possible solution, right? So we can check it. Okay. Hey, Google, what's 101 minus 2 times 44 minus 8?
101 minus 2 times 44 minus 8 is 5.
Okay. Hey, Google, what's 2 times 101 minus 5 times 44 plus 3 times 8?
2 times 101 minus 5 times 44 plus 3 times 8 is 6.
Okay, that one checks out. And last but not least, hey, Google, what's 101 minus 3 times 44 plus 4 times 8?
101 minus 3 times 44 plus 4 times 8 is 1.
Right, so we can confirm that this infinite form works, right? Again, all we did, we let A be 8. We just chose a number at random just to test it to make sure it works. We generated this ordered triple. We checked it. It worked. We can do that for any real number A, right? So I'm just going to put a green check that confirms that works, and we'll just go with that for now. Okay. All right. So that was us working it out. So let's look at, and we have a type version of this. So using row operations, eventually, see, they got the row of all zeros like we got. Okay. So then this system can be expressed as this matrix. Okay, that's fine. And here, right? So now I let, the way it was taught to me was I let Z be A, and then we wrote X and Y in terms of A, but they just wrote X and Y in terms of Z. But I think it's essentially the same thing, right? So Z, we say that Z is a free variable, and then you write X and Y in terms of Z. All right, I just call Z A, but it's the same thing. Okay, we got a couple more slides in this section, and we got a solid 10 minutes. Okay, use Gaussian elimination to solve, let me say, system with fewer equations than variables. Okay, I feel like this is what we just did. Okay, let's try it, right? Let's try it. So if we write it in augmented form, we work over here. So then we have a 1, 2, 3, 70. We have a 1, 1, 1, 60. And then that's it. When you think about it. Okay. So let's still try to get it in row echelon form as best we can. So we already have a 1 here. So we're good to go there. Let's use this 1 to get a 0 below it. So then we can say a negative times row 1 plus row 2 replace row 2. Okay. And I'll just work over here. So that means row 1 stays as is. And then row 2 becomes, this is a 0. Negative 2 plus 1 is negative 1. Negative 3 plus 1 is negative 2. Negative 70 plus 60 is a negative 10. Okay. And then let's do a negative times row 2, replace row 2. Okay. So that means row 1 stays as is, 1, 2, 3, 70. Row 2 now becomes a 0, 1, 2, 10. Okay. So then if we do the same thing we did in the previous, we can say that Z is a free variable. We can write X and Y in terms of Z. So then, for instance, that second row is saying Y plus Z equals 10. So then Y equals 10 minus Z. Okay. So that's one result. And then the first row is saying X plus 2Y plus 3Z equals 70, kind of out of space. But our Y is 10 minus Z. Okay. Cancel. So then if we solve for X, that's going to be, that's what, 20. If we subtract 20, that becomes 50. That's going to be a 2Z, negative 2Z. That's going to be a Z, so we subtract Z, so 50 minus Z. So then our variable matrix XYZ takes on the form 50 minus Z, Y is 10 minus Z, and Z is just Z. Okay. This is just us repeating what we did before. Just instead of putting A, we did X and Y in terms of Z. It seems like it should have infinitely many solutions. We could test, like choose your favorite Z, like let's let Z be 0. So if Z were 0, then it would be 50, 10, and 0. 50, 10, and 0. Let's see if that works. So let's do a test for 50, 10, and 0. Hey Google, what's 50 plus 20? Yeah, that works.
50 plus 20 is 70.
And then 50 plus 10 is 60, right? So that works for both of these. We probably should do a few more test points for Z, but I'm just not going to because in the interest of time. Okay, let's see what the prepared notes say. So first we begin with the augmented matrix. I think we got that. And then we reduce it down as far as we can get it. And then it translates into this. And then we write X and Y in terms of Z. Come on. All right, so you see X in terms of Z. Now theirs looks different. Y, they got a negative 2Z plus 10. Did I forget my 2 somewhere? Oh, it sure looks like I did. Yep, I sure did. Right here. That's supposed to be a Y plus 2Z. I forgot my 2 there. Right, let me make a note of it. This is supposed to be a 2 right here. So then this is going to be 10 minus 2Z. So it probably would have helped if we had checked a few other points. This would have been a 2z. 10 minus 2z. Okay. This would have been a 2z. 4z. Let me think. It would have been a negative 4z. Wait a minute. 10 minus 2z. Yeah, 10 minus 2z. That's a 20. So that becomes a 50. Oh, x. Let me look at x. Z plus 50. Yeah. So yeah, we missed the 2. That did throw things off. That was supposed to be a plus. And right there. That would have been a plus Z, right? I didn't correct all the mistakes, but we caught the main one that we made, but you know. So we see it here, right? It is a little bit off, but you know. Again, I'm just kind of rushing a little bit. Okay. Well, I don't really expect to get through the next section within 5 minutes. Okay. So we got through 8.1 and 8.2. I feel decent. I think I am going to go ahead and do 8.3, but I'm not going to keep you all. If there are no burning questions, I'm going to go ahead and let you all go. But I'm going to stay on the call and at least go ahead and do the next section. Okay. Again, if there aren't any burning questions, enjoy the rest of your day, and we'll meet back on Thursday, same time.